Hi everyone! In this video we're going to start discussing how to name those different groups we talked about in the last video. So let's start with carboxylic acids. Now, similar to previous functional groups we've talked about, the first rule is to find the longest carbon chain that contains the group we're interested in. So in this case, it's the carboxylic acid functional group. Then we're going to drop the E from the end of the hydrocarbon name or the alkane name, and we're going to substitute in oic acid. So then we'll number the longest chain, and the carboxylic acid group has to be at the end of the chain, similar to aldehydes, because on one side there's always an OH group. So carbon number 1 will always be the carboxyl carbon. Then we can name and number other groups or substituents that are attached. Okay, so let's look at our examples down below. So in our first example, on the left, we want to find the longest carbon chain. So we'll start at the carboxylic acid end. Okay. So it looks like we have 3 carbon atoms in our longest chain. So normally, if this was an alkane, we would call that propane. But because we have this carboxylic acid group on the end, we're going to drop the E on propane, and we're going to replace it with oic acid. So that gives us propanoic acid. Now, earlier we saw that there are also common names for these carboxylic acids. So if there are 3 carbon atoms, we could also call this propionic acid. But I think we'll just stick with the IUPAC rules, that International Union of Applied and Pure Chemistry rules, because it's just a little easier to keep track of. So, okay, and then let's look at our example on the right. So our carboxylic acid functional group is on the end. So let's just count how many carbons are in the longest chain. So there's 4. So normally, if this was an alkane, we would call that butane. But because we know there's a carboxylic acid group, we're going to drop the E and add oic acid. Okay, so it's butanoic acid. But we also have this bromine group at the front, or at the other end. So we're going to number this going from right to left, because remember the carboxylic acid group has to be number 1. So we've got 1, 2, 3, 4. So it looks like bromine is on the 3rd carbon. So this becomes 3-bromobutanoic acid. Not too bad, hopefully. But if you do see a name with that oic acid ending, automatically you know you have a carboxylic acid. Okay. Now, what if we have a carboxylic acid group bonded to a benzene ring, which is our aromatic group? Aromatic acid names are derived from the parent compound benzoic acid. So you might remember when we were talking about benzene derivatives a long time ago, one of the common ones was a benzene ring with a carboxylic acid group. And that was called, again, benzoic acid. Okay, so now that that is our parent name, we can name the rest of the molecule, because we do have 2 methyl groups bonded to that benzene ring. Now the carboxylic acid will be at position 1 again on the ring. And then we're just going to number around the ring. So it looks like our methyl groups are on carbons 3 and 4. So this will become 3,4 dimethyl, remember to put that di there, we have to be redundant, and then benzoic acid. Okay, so let's do a couple of practice problems. And I'm actually going to give you the name of the carboxylic acid, and I want you to try to draw the carboxylic acid. So we're kind of going backwards this time. So the first one is butanoic acid. This is also called butyric acid. So remember, there's the IUPAC name and then the common name. And then the other one will be 3-bromo-benzoic acid, or we can also call this M-bromo-benzoic acid. And the M stands for meta. So see if you can draw these two molecules. You can pause the video and try it on your own first, and then when you're done, we'll go over it together. Okay, let's start with the first one. All right, so the first thing I'm seeing is that prefix but, B-U-T, and that tells me that I have 4 carbons in my chain. Okay, so I'm going to draw, let's see, and I'm also seeing that oic acid, right? So I know there's a carboxylic acid there. So that's going to be on the end of my molecule. So what I'll do is I'll draw just a regular carbon chain, but I know that the last carbon will be my carboxylic acid group. And then I'm just going to number the carbons just to double check that I have 4. Okay, great. So that's my molecule. Not too bad. So now let's look at 3-bromo-benzoic acid. Okay, so benzoic acid we saw on the last slide is a benzene ring with a carboxylic acid attached. So let's draw that just to get started. And we can abbreviate the carboxylic acid as COOH. Now, I know that the carboxylic acid will be on position 1 on the ring. So then I'll just number around the ring. It doesn't really matter which way we go, either clockwise or counterclockwise. And I know that at position 3, there is a bromine. So I'll just add a bromine there. And that's our molecule. Okay, so now let's talk about how to name esters. So esters are composed of the carboxylic acid part, so this part here, where R is an alkyl group, and then it's also composed of an OR group on the right. So for example, let's say we have the following ester. So we have our carboxylic acid part, and then we have our alcohol part, OR. So when we're naming an ester, the first word of the name is the name of the alkyl or potentially aromatic group that's contributed by the alcohol. So this part on the right, it could also be on the left depending on how you draw it, but the alcohol part will be the first part of the name. And then the second part of the name will be the carboxylic acid part, but we're going to change the ic acid ending to ATE. So we're changing, for instance, let's say we had, let's look at butanoic acid on the last slide. What if we replaced the H? Oh, let me actually just erase that. What if we replace that with CH3? This would become an ester, right? So we're going to name the part that is on the end next to the oxygen first. So that is methyl. And then we're going to name the carboxylic acid part. So initially it was butanoic acid, but we're going to replace the ic acid with ATE. So it becomes butanoate. So the full name of this ester is methyl butanoate. But let's look at some other examples too. Okay, so let's look at the first example on the upper left. All right, so we've got our carboxylic acid component on the left there, and then we've got our alcohol part on the right. And we're going to name the alcohol alkyl group first. So that is methyl. And then we're going to name the carboxylic acid part. So let's see, there's 2 carbons. So normally if this were a carboxylic acid, we would call that ethanoic acid. But because we know this is an ester, we're going to replace the ic acid with ATE. So it becomes ethanoate. So the full name here, let me just make some room. The full name is methyl ethanoate. So if you see that ATE ending, then you know you have an ester potentially. And if you see some sort of alkyl name in front, that definitely confirms that you have an ester. So essentially this name is kind of telling you, okay, so ethanoate, you've got 2 carbons with a double bond to oxygen on one of those carbons. And then on the other side, you have an oxygen bonded to a methyl group. And I know this is really confusing at times. Naming esters is probably one of the most difficult things to do. It's my least favorite thing to name. But I'm going to try to make it as simple as possible. Okay, so now let's look at our second example to the right. So again, we're going to find our carboxylic acid component. All right, got that. And then the rest of it is from our alcohol. And then we're just going to name the alkyl group or aromatic group that's bonded to the oxygen. So in this case, it's a benzene ring. But remember, when benzene is a group that's kind of attached to something else, we call it a phenyl group. And then the carboxylic acid part has 4 carbons. And we already said that that was butanoic acid. But again, we replaced the ic acid with ATE, so it became butanoate. So the full name is phenyl butanoate. Okay. Now let's look at our last example. So again, we're going to identify the carboxylic acid part. And that kind of looks like benzoic acid, right? Okay. And then the other part has an ethyl group on it. So 2 carbons. So ethyl is the first part. And then we said that the other part kind of looks like benzoic acid. We've got that benzene ring connected to what was the carboxylic acid. So we're just going to replace the ic acid with ATE, so it becomes benzoate. So that'll be the second part of our name. So the full name is ethyl benzoate. Oh, that kind of looks like an E. Let me make that more of an L. Okay, so let's do a couple of practice problems just to really kind of hone in on this. So what I'll do is give you the name of the ester, and then you have to draw the ester. So again, we're going backwards. So the first one is called ethyl propanoate, and the second one is called propyl ethanoate. So it kind of looks like they're switched almost, but see if you can draw these on your own. So you can pause the video, and when you're done, we'll go over them together. Okay, let's start with the first one. So the propanoate part is the part that tells me how many carbons I had on my original carboxylic acid, right? So prop tells me that I had 3 carbons. So I'm going to draw just a regular carbon chain. The third carbon has the double bond to oxygen. And then that ATE is telling me I have an ester. So I'm going to draw an O next to that. And then the first part of the name is ethyl. So that tells me I had a 2 carbon chain on the other side of the oxygen. So if we kind of highlight what's going on here, we've got the first part of our compound, propanoate, and then the second part, ethyl. All right, let's look at the next one, propyl ethanoate. So this is kind of switched around, right? So ethanoate is telling me how many carbons I had in my original carboxylic acid chain. Okay, so it was 2. Oh, here we go. I almost drew an H next to the carbon. There we go. Okay, so that's my, what was my carboxylic acid, but the ATE part of the name tells me I have an ester. So I'm going to put an O next to that. And then the first part of the name is telling me the carbon chain that's bonded to oxygen. So that tells me I have 3 carbons. So I'm going to draw a 3 carbon chain. Okay, so we've got our ethanoate component here. And then we've got our propyl component on the other side. All right, so I think we'll stop there for this video. I'll also post a worksheet with some practice problems for naming because I know that this can be a little overwhelming. Next time we'll focus on naming amines and amides. So I will see you then.